Okay, the record is on, so my apologies again. Anyway, we are here, right? We're talking about this material available in the Thai market. Generally, for structure, we should use the one called SM400, but somehow they just got familiar with this. So in Thai market, instead of using SM400, we use SS400 instead. In terms of strength, they are essentially the same. There is a difference in terms of the ability in welding, the quite specific characteristics in those areas, but we're okay. Insofar, it doesn't matter, so to speak, and you cannot order SM400, and the company like the SYS, it just asked me, could you please refer to this as SS400 because we don't actually have it in the market. So yeah, maybe from time to time you will see me say SM400 because I'm so used to it, or in some part of the lecture or the examples it still say SM400, but please you know, be mindful that in fact we use SS400 only in the market. But nowadays we also have the SM520. Okay, so now it's safe to say that you have two steel grades that you can use in the market. Now the bigger number means the bigger strength, and so the better, right? Yes, it should be better in terms of strength. And now in terms of the price, they are pretty much the same. So there is no reason why you should not use the stronger one. Okay, the numbers here are in the Newton. So let me say that generally here, right here, SS400. So we have SS400 and SM520. The FY right here is roughly 2,500, and for SM520 it's 3,700. Okay, and for FU here is, because the number is right there in the middle, so you can use 4,000, but you can use 4,050 as well, just slightly more. Okay, and this is 5,300. So basically, you know, this is something that you need to identify at the very beginning of your project in your design criteria, which material you are going to use. This is very important. And generally, ladies and gentlemen, I can tell you right now that it is a much better idea to use just one material per one project, even though it's going to be safer in some cases, but we are not going to change the material around in one project because it can lead you to complete confusion and difficulty in, you know, say quality control, to say the least. So you have to make up your mind quickly in the beginning of your project. First, what law that you need to abide, just check all those requirements on the law and stuff. And second, choose the materials properly from the beginning. Okay, so if you're talking about something in a class, you must be able to identify the materials that you use and use the proper strength in your calculation. So we can come back and take a look at this. Right here, it's the here you see the number 2 here, right? You must be able to identify your criteria correctly, and you know which material you're going to use, and therefore which yield strength and ultimate strength that you must use in your calculation. Okay, if you fail to do this from the level number 2, you know, the rest is useless because you are using the wrong material in your work. All right. So that's that. Now let's get to know the shape first. Now this is the shape taken from the US of A. They have so many shapes, but in our country, let's say we have only for typical building that you are going to handle in this class, we use this one for the majority. They call it Y flange because the flange is Y. Sorry, but that's true. This is called also the H shape in the, our country. So let me, try to give you some idea of this. Okay, so let's say the H shape looks like this. Okay. Generally, okay, now let me finish this first. Now I deliberately draw the top and bottom portion thicker than the middle portion, which is true. This portion we call the flange. Okay. Now in Thailand they call it beak, like the wing. I don't know why. So this is also the flange. And this is the web. Now, do you know what's called in Thailand? It's called Eona. So I don't know. I don't know who came up with those words. I don't really particularly like them, but this is how they are called. And in Thailand, they have the Thailand industrial standard to make sure that all the H-shape manufactured in Thailand must be according to the sizes assigned by TIS. And in TIS, they have their own nomenclatures for stuff like this. And they have, I don't know how they call this, but the width here in the AISC, they call this BF. Basically the width of the flange, okay? And the total depth, they call this D. Okay, I'm not sure what the TIS call, but what I can remember is that this TIS called T1, but I'm going to call it TF. This is much better, so that we know it's the thickness of the flange right away. And here we call TW. Okay. Now, things that you need to know also that this is called the manufacturing of the H shape in Thailand is such that this is part of the circle. So we are having this associated with this quarter circle. This is called R. This R is a radius, but it's not the same as the radius of gyration that you calculate from square root I over A. Okay, it's the radius of this so-called fillet. This portion here, this is called fillet. And the radius of your fillet is denoted by R. Okay. Now, the things you need to know about this is that there is also a special character not available on TIS is the distance between the fillets. I should change the color. Like this. The distance between the fillet is the clear distance that engineers can use to determine how much space that you have if you want to build the connection in between the web area. And this is called T. Okay. And one more thing that it's a very important character in the US is this distance. But in Thailand, it's not a big problem because we have only one standard, that is TIS. So the fillet is always built in the same way. But in the US, they are free to manufacture the section to a certain extent. So that they can have different R's. So that's why they need to come up with something to define this distance, and they use it as a K. So basically K is the thickness of the flange plus R. Okay? So this is the common character that you should know, and this is called the H shape. So let me show you this. I don't have it, so let's just a second. Okay, I thought I brought it. Okay, maybe this one. 1 second. This is the special table that I have developed myself in association with the SYS. So you can be sure that all the properties are calculated correctly. As you know, that the steel catalogs, they are only required to give the information based on the TIS, the Thailand Industrial Standard. So some important engineering characteristics of the section are not presented in those catalogs. So that's why I have a special table and already given to you. So you can use this to your own benefit. Okay, so in this table, you will see that we have the area, the depth, which is D. Now we have TW, we have BF, we have, I use this one, we have TF, the thickness of the flange. We have the K value, as I just mentioned, and we already have the T value. Okay, there are so many useful engineering properties afterward, and we'll come back to talk about this when the time is right. Okay, but now please keep a good hold of them. But anyway, if you lose one of these things, you can always ask for more from your friends, right? But I also think that it's going to be there forever on the Google Classroom. You can always come back and get it. Okay. Anyway, one more thing you one more thing you need to understand is that this is called the H shape or the Y flange. Some call it Y flange. I believe the TIS called is an H shape. Now, there is one quite similar section. It's called I. You may have heard of it, I-beam, stuff like that. Now, when engineers mention the I-beam, you must know that the I-beam is not the H shape nor the Y flange. The I-beam is referred to the beam that looks like this, you know. The major difference between the I-beam and the Y flange or the H is that here. For the I, it's kind of difficult to draw. The I, this is the I shape. The flange is tapered. This is what we call tapered. So it's not like the parallel straight lines for the flange like this one. You see, this one is the perfect rectangle, but here is tapered. Tapered. So when you refer to your hot roll as the I shape, you are referring to this one. Generally, it has its purposes for the rail that you use in the factory maybe, or some structure for the train and stuff like that. But typically for the buildings and you know, structures related to buildings, we use this one. Okay. We use the Y flange or the H shape. So when you refer to the Y flange, you are referring to the H shape. You don't say the I, because the I would mean a different section. This one, generally speaking, has a lot less selections, and it is harder to find the market as well. So call them by the correct names. Okay, because you are engineers, you must be able to communicate with your colleagues, and you must refer to the stuff that you use correctly. Okay, so is there any question about this? Hello? I suppose we're okay, right? So, okay, predominantly we are going to use this one. So we just the rest. Oh, okay, one more thing I forgot to mention, that when we call this, generally it's by the nominal strength. You can see from here. You can call this 100 by 100 by 17.2, you know, the nominal size of it, followed by the weight. Generally, that should be enough, but somehow in Thailand, you will see in many places they would call this something like 100 by 100 by this, and then followed by the thickness of the flange and thickness of the web, and then the thickness of the flange. So they may write down like 100 by 100 by 6 by 8. So that's many times engineers refer to the steel section like that. But let's say in the US, they would just, okay, name this and then the weight. And you can see from this that that's the second one is the weight. So they just refer to as W12 by 50. So in their unit, W12 would be 12 inches, and 50 is 50 pounds per foot. Okay, but in our country, we refer to something like this: 200 by 200 by 20 by 8 by 6. Okay. All right. So you can also use the channel. I believe that I have the channel for you as well, and the angles and so and so. But predominantly in this class, you know, you will be introduced to the H shape or the Y flange, the use of them. Okay. One more thing, do I have it here? See, so the T actually is cut from the Y flange. It used to be quite popular, but not so anymore because it's kind of expensive a little bit. Generally, when you make the cut T, you cut the Y flange into 2 pieces. That's all. So, you know, what used to be so popular for the truss, because they can use the T for top and bottom chord, and then they can you know, put things together very easily. But I don't think it's that popular anymore. Anyway, and we have like angles, and we have this. Now, these sections are popular. I don't think I have posted that for you yet. I will do it. I will do so very soon afterward. We can use this square, rectangular, or pipes to create the truss. This is hugely popular. Okay, and we will get to this soon enough. The way we tell the section is not different from you know, the H shape, but sometimes we will refer to the size and then the thickness. Okay, this is the diameter and then the thickness. And you must be aware of this a little bit, because when you use this, the materials that they use to manufacture these sections are not SS400 nor SM520. They use another material according to TIS. If I'm not mistaken, the number is TIS 107 for these sections. And the FY is not 2500, FY is 2400. So be very careful. And I will be very, very mean if you use the wrong number, because you make a mistake in the classroom, it's fine. You get bad points. But if you make a mistake in real life, you can't sleep well, you know, and you wouldn't know what's going to happen afterward, right? So I would try to eradicate mistakes like this out of you in the class. And FU, I'm not sure, I need to check, but I suppose it may be 4,000. It's put a question mark on it. I need to check. I don't remember. Okay. All right. Now, one big issue for the use of the steel is the fire protection. Now, I'm not going to go into details because in the end, this is done by architects many times. You only need to know that we have two ways to protect the steel from the fire: the active system and then the passive system. Oh, can you tell what the difference between them? The active is something the system that active, so it prevents the fire from coming to steel. For example, the fire alarm. Okay, the fire alarm would be the active system, or the sprinkler. And folks, it's sprinkler, not sprinkler. That's wrong. Okay, it's sprinkler system. Okay, but the passive is something that you are on the defensive. You let the fire come to you and you try to protect the structure. For example, the paint or the cementitious material. You can see from this picture. Okay, see that's the paint. You try to paint the structure. And this is the cementitious material, the material that looks like cement concrete. So they just sprayed on the steel structure to help increase the fire protection. Generally, the fire protection is measured by the hours of the material that can withstand the fire. Now there's a major struggle in Thailand to try to change the law according to the fire protection, because this is the it's like the abortion law, because they just make it so very expensive that many people are so afraid to use the steel structure because they have to pay a lot for their fire protection. Currently, the law states that any steel structure must be able to maintain, to withstand the fire for 3 hours. That's absolutely crazy. So, of course, we can make the steel structure withstand the fire for up to 3 hours, but it's going to be very expensive. For example, if you are going to use the paint to increase the fire protection to 3 hours, you're going to have to paint very, very thick. So you have to pay a lot more for the paint and for the cementitious material as well. And I can tell you that architects don't like this very much because they don't look very beautiful, do they? You think? Okay, anyway, so that's pretty much about a fire protection system. But it's part of your engineering concern. Okay, and you can read more about this, the details. But let me go over it quickly because we don't have that long hours anyway. So here, you can see that's a cementitious material. So if you want to spray your roof structure, it's going to look like that. It's not very beautiful, is it? Okay. Anyway, now let me go over this a little briefly, because have you guys had structural analysis number 2? Hello? Hello, have you had the structural analysis number 2? Hey, we still have a class, right? Anyone?
We're having it this semester.
Oh, I'm so glad I hear someone. Okay. So you have had it? Structural analysis number 2? Oh, yes. So the answer is yes. Thank you. Anyway, we should know that, as I have mentioned earlier in the class, that it's our job to make sure that our building can withstand the load according to the law. Now we can group the force on the structure into 2 groups, the vertical load and the horizontal load. Okay, the vertical load, you can call that the gravity load, because I think all of them is induced by gravity. So you can say it's gravity load, the dead load, live load, and so on and so on. But we also have the lateral load. Okay, that is the wind and the earthquake. So it's our job to provide the proper structural system so that the building stands. So now you must know that what kind of system can withstand the vertical load and what kind of system can withstand the lateral load. Okay, but generally, I cannot say about all the classes, but I myself would try to provide some knowledge in the structural analysis class that, okay, the reason that we need to study the frame is because the framing system is the system for lateral load. Without them, without the proper knowledge on them, we engineers cannot design the structure. So we have the gravity load in the vertical direction, and then the lateral load in the horizontal direction. Say see vertical load and then the horizontal load. Okay. Now this is going to take very long, and I'll try to go as quickly as I can. Okay. Generally, when you start building something, especially the steel, the system to withstand the lateral load is always a concern. So we must make sure that we have a system to withstand that. Okay, and there's so many things that you can choose. For example, the brace frame like this, 2 brace frames. You can use the shear wall. Have you heard of it? Right, the shear wall is just actually it's just a something that looks like a beam, yeah, but it's on the vertical direction, what they call shear wall. There's a system to withstand the lateral load, and then the frame. Okay, so if we talk about if we talk about the structural steel system, we can forget about the shear wall, that's concrete. So you can have either the frame system like this, or the brace system like that. So the major difference is that when you have the bracing system, you can turn the forces into the axial forces, but you will lose the space here. So you cannot always have the brace frame anywhere in your structure because you cannot walk through them. You lose the usage of the area. So architects will not allow you to have like this all over the place. So when you cannot have the brace system, you're going to have the rigid frame system instead, where you make this joint a rigid joint. Okay, more on that later. So now let's take a quick look at the gravity load system. It's just basically the floor beam system. Okay, like that. Generally for steel structure, you can put the concrete floor on the beam like that. Then you provide the beam here. Okay, and this beam will carry the floor, which comes in this direction. Okay, so that's basically a system. Or you can have, okay, and maybe you can have the secondary beam system, put the floor on them, on these secondary beams, and then this secondary beam in turn is going to be supported by the primary beam. Okay, to make it clearly, this is primary. Or sometimes they call it the main girder. This is the secondary beam. Or sometimes they call it filler beam. Okay, so maybe we'll try to find some time to talk about this system more in the design lab in the special session. Okay, or you can, instead of putting the hollow core concrete slab on top of the steel, you can use the composite construction by using the metal deck. Now this system is very popular abroad because it's very quick. You have the composite steel deck like this. You attach this to the steel beam by using the shear connectors like this. Of course, you have the equipment that can be done by only a single person. You just use the equipment and bang, 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 bang like this. Then, or the entire floor system can be done, say, in hours. Once you attach the metal deck to the beam, you pour the concrete on top of them like this, and the system of composite construction can be formed. And now you can basically have the strength of the steel and concrete work together. So it's a very strong system, but you must have the shear connector for the system to work. And now the shear connector in Thailand is still quite expensive, so it's not that popular, but it's becoming very more and more, say, viable in terms of economy and so. So, you know, maybe in the future, you're gonna have more of this. Okay, so this is what it looks like. Let's put the shear stud on them, you know, on the metal deck, and then pour the concrete. And generally, we cannot cover the design of a composite construction in this class, but you, as I mentioned a few seconds earlier, if you can make concrete and steel work together, you're going to have a very strong system. And let's say if it's a typical positive moment, you will have the steel beam like this, and then the concrete on top in the metal deck like that. And you guys know that if this is a positive moment, it means that on top is compression, right? And at the bottom is tension. So we are trying to use concrete on the compression area and steel on the tension area. So the system is very strong, but you have to provide the details so that they work together. Just like in mechanics of materials, when you study the composite materials, you remember that? Anyway, so there's some disadvantages. Say here, the field cost for the installation of this takes time, especially in our country where shear stud is expensive. Okay. All right. So this is it, metal deck, and this is the shear stud that I mentioned. Okay, you use the special equipment to weld this right on top of the metal deck. So it's very quick. There, like that. Okay, now, so that's a vertical or gravity load system. I'm not gonna go into this lateral load system because we are approaching our second break. Okay, still have 2 minutes left. So let me put a break on here and ask if you have any question. I'm afraid that I may go over this too quickly. So this is quick enough. This is quick, but maybe not enough. Anyway, so you guys have any question?
No,ครับ.
No. So again, my apologies on the crash of the Zoom. So beyond my control, never happened to me before. Let's hope that the record is still okay. I can still convert that later, I hope. Okay. So if that's not the case, it's time for the second 10-minute break. Okay, or would you like 15? Because 3-hour course is very, very gruesome, you know, so demanding. So, okay, that's quick. Yeah, generally I would give the second break 15 minutes, 15 minutes, KMUTT as well. So let's have 15-minute break. So we come back at 10:35, okay?